Hey everyone, welcome to this new exciting video where we're going to add 3D objects to our scene and apply materials to them. What you're currently seeing is the end result of this video. So what we're going to do is add those objects and build a foundation so that we can also add those objects in the rest of our scene and apply the materials to them quite easily without too many difficult code. But we're not going to be able to address everything, such as the floor, for example. You see it's a different color. And same with the physics, because currently we can still drive through it. But yeah, that's all going to be handled in the future video. For now, let's get started with this. Now let's get started with the index file inside of the world folder, which contains basically the class that gets used for everything that's in this world. Now in the constructor, you'll see that it sets up a few things like the sound, the controls, the areas and the starting screen, which are needed for the initial screen. And as soon as you press the start button, the start function will get called, and then everything else will be added as well. It will add, for example, the materials, the shadows and the physics. But most of all, for this video, the most important part is that it's adding or setting the sections. And if we go there, you'll see that it's setting a few different sections. The project is divided into 5 different sections. For this video, we're going to look into the intro section, which is where you start this area right here. So if you go there, you'll see that it contains 6 different, that it calls 6 different functions in this class. The setStatic function handles all the static objects in our scene, so that's like the trees and the rocks, for example, because you cannot interact with them in any way. They are basically just there for decoration. But for example, the arrow keys right here, or the text that you see below it, those are not static. Those are part of the instructions function. Then we have the other instructions right on the right side here with some additional instructions. Then we have the text Bruno Simon written in those blocks and the creative dev blocks, which are part of the titles. The tiles are those little tiles that you see right here. And the dikes are the blocks that you see on the side and on the right side as well, right here. So yeah, that's all handled inside of this intro section class. For all the other sections, it's a little bit similar. So we have 5 different sections which all contain their own pieces that are relevant for that section. So for example, here you'll also have a few tiles. You'll also have a static scene because it contains this block which is not interactable, and so on. Now I can imagine that this might be a little bit confusing because here we are actually setting all those objects, while in the world class we already added all those objects as well, or we set them. So here, for example, the set objects and the set materials. So what is this doing that's not being handled in those functions then? And well, basically what's happening is in those functions we're just initializing the classes. Same for the set objects, we're just initializing the objects class. And in the actual section classes, we are really specifying which objects we want to add. So initially it's just an empty class, and we're adding specific objects to that. So for example, the scene for the static intro objects, and so on. Now don't worry if that was a little bit vague to you, because we're going to do it different. I'm going to show that with this setStatic function. We're going to add the static scene to our scene as well, so the trees, the rocks, and so on, but without actually having to initialize anything. And for that, we're going to the world component, which is currently only returning the floor, but we're going to let this return something else as well. So I'll have to wrap it in a fragment, and then I can add the let's add it after the new component that we're going to add, and let's call that the intro section component. Now this component doesn't exist yet, so let's create one at the same location as where the previous sections were. Intro section component, and let's create a React functional component here. And what we want to return here is basically a very generic object that will handle adding the object and adding the materials to that object, including the shadows, everything automatically. Also the 3D physics should be handled in there, because we're going to reuse that component quite a lot on different places. This is not the only place where we have static content. So the way we're going to do that is we're going to return one component here, which I'm going to call FolioModel, and we're going to pass specific arguments to this component, which are specific to the static intro scene. Now this FolioModel component doesn't exist yet, so I'm going to create this. I'll create it in a new folder called components, because it's so reusable, and let's call that FolioModel.tsx and create a React functional component in there again. And yeah, so basically what we want is to be able to pass like the path to the actual object inside of this FolioModel, so that that one can be retrieved, and then that can be returned. So we're going to allow a path as an argument to this FolioModel, and that's going to be of type, well, let's make it an interface. So FolioModel props, and path will be of type string. And this path, we can use that using the use GLTF hook from React 3 Dre, and that will give us a GLTF in return. If we pass the path in there, then now we'll have access to the actual GLTF file, which in our case will contain the trees and the rocks. And in here, we're not going to return a div, but we're going to return a primitive, which contains an object that will be the GLTF scene. And we'll have to auto-close this. And that's basically enough for a very basic version of the FolioModel. But now we still have to specify the path in our intro section, of course. And that's gonna have to be the path to our 3D model. And the models are currently saved in the models folder, separate from the JavaScript folder, which contains quite a lot of models. In here we have a intro folder, and in there we have quite a lot more folders, but one of them is the static folder, which contains a base.glb. You also have a collision.glb file, but we're not going to look into that one yet because that's really related to 3D physics and we're not there yet. But I'll leave a picture on the screen about the that showcases the base.glb file, so that you have an idea of what we're actually loading in here. But the thing is, we're going to have to load that in from the public folder, and currently the models are saved inside of our source folder. So what I'm going to do is I'm basically going to move this models in its entirety, or actually copy it over to the public folder. I don't want to move it because the old three.js code that Bruno Simon wrote is still using the models right here. We want to use it in the public folder because that's how React 3 Fiber expects it when we use the use GLTF hook, for example. I'm going to paste it in here, and then in the intersection component I'm going to specify the path relative to the public folder. So that will be models intro static base.glb right here, and that's the one we're loading in. Now we'll still need to import this component and do the same here. Save it, and well, there we go. It doesn't look beautiful, but you can see that something is happening at least. Now the problem here is called Z fighting, which is happening when two models are exactly on the same position, which is currently the case because in the old 3.js code, Bruno added the model himself, with the materials applied to it, and we now added the same model without any materials applied to it, so everything turns black by default. And that's because they are on the exact same position. It's like fighting to be shown or not, and that's what makes this flickering happen. But we're going to fix that, of course. Now, first of all, let's remove the old 3D objects, at least the static ones, by going to the intro section.js file and, well, just copying out the setStatic function call. So now you'll see that the old ones are gone, and our new one is shown, but it's a bit hard to see because it's all black. So we don't see that the objects are actually here, but trust me, they are there. So yeah, the next thing we're going to look into is actually applying the materials. And for that, I'll first show how Bruno did that himself. So I'll go to the materials.js file, where you can see that he's including 3 different types of materials. He's setting pures, shades, and he's setting the floor shadow. Now, pures are basically mesh basic materials, which means that they will have a single color and are not affected by light in any way. And those are, for example, used for the lights on the car. Then we have shades, which is what you see most of the time. So, for example, the orange or the green colors, those are all shades, and shades are actually made of a custom Matcap material. So this is not the Matcap material of three.js itself. It's a custom one that Bruno Simon made himself. And then we have the floor shadow, which is used to showcase the shadows on the floor. Those are not generated with lights in this scene, because this scene doesn't contain any lights at all. Those are all created with materials and textures. Okay, so let's go to the shades for now, because that's what we're gonna need for the black area that we have here. And I'll first show you the actual matcaps that are currently being loaded in. So that's in the models folder that we moved over or copied over to the public folder now. And in there we have a matcaps folder which contains all the different colors. Now, for example, the brown one looks like this. And we're going to load in all those matcaps and use them in the custom material class that we're going to create as well. So the Matcap material that Bruno is using is this one in the materials folder, the matcap.js file, which is currently a function, and we're going to convert this to a custom material just like we did in a previous video. So this time I'll go over it a little bit faster because we've done it before. So what we're going to do is copy over the matcap file and rename it to FolioMatcapMaterial.ts. So it's TypeScript. And we're going to make this a class instead of a function. I'll give it the same name, of course. And instead of returning the shader material, what we did before, we're now going to extend the shader material. And this code can all live inside of the constructor. Let's cut that and put it in here. Now, this is complaining because we need to call the super before. So let's do that. And actually, we want to call the super with some of the options that we are setting here. So let's move it down and yeah, use what we used to pass to the shader material as the argument, like this. And we don't need to return that material here anymore. Now there are some additional things here, such as the extensions and the defines, which are actually not necessary because the extensions, the values that are set here are actually the default values. So we don't need that. And the defines, we don't need that one either. So I'll remove those to make it a little bit more easy to read. And for the uniforms, we will need those for the actual shader material. So those are some of three's uniforms. and those are the ones that Bruno Simon added himself for this specific material. And the values are currently set to null, but what Bruno did was he was setting them inside of the materials class to those values. So I'll copy those over like that. Now for the indirect color, I wrapped it in a new color from three.js because that's what the material is expecting. And we're still getting an error about the matcap that cannot be found. So the matcap is something that we're gonna have to pass to the material, and that's gonna be a type texture. And we'll have to load that in before we're actually using this material. And that's actually everything. The wireframe and transparent are actually also default values, so I can remove those as well. And let's save it. Okay, now next thing we can do is actually use this material in the FolioModel component. But we cannot apply it directly onto the GLTF or onto the GLTF scene, because every object in here has its own material, because the tree, for example, is green and the ground was orange. So we'll have to actually loop over all the objects in this GLTF and apply the material based on some metadata of that object. And the way we're going to do that is we're going to have a use effect, and in there we're going to loop over all the objects in the GLTF. So we'll have gltf.scene.traverse, which means it will loop over every child, and we'll have access to every one of them. So first thing we want to do here is to check if it is actually an instance of a mesh, because if it's not, then we don't want to apply the material. So in that case, we just want to return. Now if it is a mesh, then basically what we can do is we can set the material of it to the new FolioMatcapMaterial. And we'll need to pass the matcap right here, and we don't have access to it yet. So let's get that here with the use texture hook from React Read Array. So in here we'll have to specify the path, and for now let's just get the one of the matcaps. It doesn't really matter which, just to see if we can get any color on it. So we'll go to models, matcaps, and then brown.png. So that we'll actually have access to the matcap, and let's pass that one to the FolioMatcapMaterial then. And as you'll see, everything disappears now, which might not have been what you expected. But it is actually correct, because this is the initial state of the website. And that's also the default value of the material. It's setting the reveal progress to 0, which means that it isn't shown at all. Now if we would go to the official website, you'll see that it's also not there, but as soon as we start, it is slowly appearing right here. And that's what this reveal progress uniform is actually for. We're going to animate that later on, but for now, if I change it to 1, so that it's fully revealed, you'll see that everything appears here. Now, of course, we don't want everything to be orange, so we're gonna have to specify in the FolioModel which object needs which color, and that's actually part of the child name. So if we would log the value of the child name, you'll see that it contains which color it should actually be. There's no such thing as metadata in the 3D object available, so I think Bruno therefore decided to add the color of the 3D object to the actual name. Now if I show you the logs, you'll see right here that it's logging a lot of different values for every single object. So the first part specifies that it's a shade. If you remember, we had the pures for the single mesh basic material colors, and we have the shade for those matcap materials. And then after that, it's specifying the actual color. So that's white here, and green, brown, so on. And so what we're gonna have to do is we're gonna have to get all the textures initially, and then based on the name of the actual 3D object, we're gonna specify, okay, we want to apply the FolioMatcapMaterial, but with the matcap of that color. And I don't want to add all of that code right into this FolioModel component. So what I'm going to do is I'm going to add a custom hook for that. So let's add a hooks folder and a materials folder in there. And in there we're going to create a new use get material hook, which we're going to use specifically for that. Just going to export a function use get material. And in here we'll actually get all the matcaps in the first place, and then we'll return a function which accepts a child name. So we're going to pass this child name, and then based on that it's going to return a material. In our case for now it will just be a FolioMatcapMaterial in any case. But later on, when we also add support for the pures and for the floor shadow, we'll also return different kind of materials. Okay, but first let's get that use get material hook to work with our single matcap. So let's copy this over to this new function, this new hook. And we're gonna have to return a get material function here that I'm going to create before. If I can type. And that function accepts a child name, and the child is one of the 3D objects in this case. And that will be of type string. Now let's initially just return a new folio matcap material here with the matcap that we retrieved on the top. And return that function so that in the folio model we can now use that get material function from use get material, and in here we can now set the material to get material instead of initiating it here. And we'll have to pass the child name that we have available here. Now this will still return the same material, of course, because we only get that one texture. We'll always return that. We're not using the child name yet, but this is just to get the same result using a custom hook. And that works. Cool. So the next thing we're gonna have to do is retrieving the actual color from the child name, because the child name of course contains more than only the color. And the way Bruno did this in his project is if we go to the objects file, you'll see that here you don't have to understand all of this code, but basically what it's doing is it's using a regex to retrieve the color, and then it's converting it to camel case from Pascal case. Yeah, this is quite complex to read. So what I did is I created two small helper functions that I'll copy over here. So the first one is get matcap color, and the second one is to camel case, which is being used by get matcap color. And this function, we're gonna use this to convert basically the mesh name to only the color, which is of type string. So in here we can get color using get matcap color, and then we'll pass the mesh name. I see I called it child name. Let's be consistent here. And this will be of type string or undefined in case the mesh name doesn't start with shade, which means that it's not a matcap, that we shouldn't add a FolioMatcapMaterial to that object, which is for example the case for shadows. Okay, so the next thing we're gonna have to do is get all the matcaps inside of this hook, because we're not allowed to run this hook inside of this get material function and then get one texture at a time. So what we're gonna have to do is get all the textures beforehand, all the matcap textures, load them all in, and then when we call the get material, we're gonna pick one of the values out of that object. And the way we're gonna do that is I'll copy over a list of all the different colors that are available. you can actually see that that's the same list as all the matcaps files right here. And we're going to map this to a two-dimensional array. I'll show you why in a second. So I'll call this the use texture argument that we're going to pass inside of here. I'm going to map the MatcapMaterial colors to an array where the first argument is going to be the key, which is the color, and the second argument is going to be the path, which will be this value, but then instead of brown, we're now going to change that to the specific color. Let's save that. And now we get a two-dimensional string array with the color as the key and the path to the texture as the value. Now the nice thing about this is that we can use object.from entries and pass that as the argument. And this will give us in return an object with the color as the property and the path as a string. So that will look something like the following. For example, brown, and then here the path / brown.png. And the same for every other color. So if we later on want to add another color, if we ever decide to add one, then we can just add it to this array and it will automatically be added here as well. So let's replace this back to the use texture argument. And there we go. And the reason we're doing it this way is because now inside of this function we can easily pick out that property and then we have access to the texture. So I'm going to rename this to matcap textures, and in here we can easily get the specific matcap by checking the matcap textures and then getting only the color out there. Now this is not going to work because color can also be undefined in case we're not returning a matcap material. So we're first going to have to check if color is set. Then we'll return this, and otherwise we're going to have to fall back on a default case. And what Bruno did himself was return a mesh normal material in this case. So we'll do that as well. And you'll see that the floor is now a mesh normal material because that's not a matcap material, but everything else should be working now. Awesome. Now I can imagine that this was quite hard to follow, especially if you're quite new to React or TypeScript or three.js. So don't hesitate to ask me any questions. I'm really looking forward to answer them in the YouTube comments. So feel free to ask your questions there. The good part is that we finished the most difficult part now, and that in the next video we're just going to tweak this use cap material hook a little bit more and finish it up so that we don't have to look at it anymore and it just works in this FolioModel component. So yeah, that's it for this video. Thanks for watching. Don't forget to like and subscribe, and I'll see you in the next one.